Okay, so let's talk about rational exponents. So what are rational exponents really? What do they look like? So it's a kind of this radical format. So we have the radicand, the radical symbol, and then we have kind of this root and this power, right? This is kind of where the exponent is. And so we get this base with some power and root. And so if I'm kind of thinking about it, right, this is kind of this a to the m over n power, where a is the base, m is some exponent we're raising our value to, and n is some root that we're trying to find. And a lot of people really still have a hard time with power and root, so let's kind of go through this. And really all we want to do is take situations that are in radical form and put them in rational exponent form. And then likewise, if I have something in radical, a rational exponent, I want to kind of write it as a radical. Rational exponents and radicals are really kind of the topic. How we kind of rational exponents and radicals, how we kind of move back and forth between them for presentation, because they have useful differences. So we recognize that we have a base of 5. So we're going to have this exponent here, but it's going to be fractional. And how do we determine what that fraction is? Well, I don't see a number here, and I don't see a number here, so how can I determine it? Well, anytime there's no exponent, there's a power of 1, and the power goes in the top. And since this root symbol has an implied 2 when there is no number there, the denominator is 2. So in fact, anytime you see the square root symbol, it means something to the 1/2 power. That's really what it means. Some value, it could be x, could be anything, but it means something to the 1/2 power. Alright, so that means that I have these two things, but they're both underneath it. So I could write it two ways. I could write it like this: x to the 1/2, comma y to the 1/2. That's a little busy, but another way that's presented is I could present it in parentheses. So these two things mean the same thing, right? I could distribute the 1/2 to both of these, and I get this. So both of these could be presented. Over here, we do have to take into consideration that j times k raised to the 1/2 power, that j is not in receiving the exponent, so I would just take the square root of k, and j just stays out front. Notice I just took the k and put it inside the square root symbol. Of course, there'd be a 1 here and a 2 here. We don't write them, they are implied. So over here, let's just rewrite everything with the 1/2 exponent. So I'll have 25 to the 1/2 power, x to the 1/2 power, and then y to the 3/2 power, right? Okay, so how did that happen? Because another way to write this is 25x y to the 3rd, all raised to the 1/2 power, right? We notice we took everything underneath the symbol here and we put it in parentheses, which means I have to distribute that 1/2 root to each of these, which means that technically I am taking the square root of 25, so I can just leave that as 5, x to the 1/2, y to the 3/2, and this would be our answer here. Where over here, although that's our answer, it is best left with j times the square root of k. Okay. Over here on this one, so kind of building forwards and backwards, kind of seeing how it moves from one to the other, we have this 81, and so I'm going to put all of these, 81 here, then the 3rd power, right? So I'm taking the square root of x and raising it to the 3rd power, and then I'm taking the value of the square root of y and raising it to the 2nd power. So this is a little tricky. So the square root of 81 is 9. I do not have this, so I am going to kind of leave it here for a second, but then I have this y. So let's just rewrite this as x to the 3/2, and then y to the 2/2. Well, y to the 2/2 becomes 9x to the 3/2, just y. So if I want to kind of organize it so it has a radical, since I have this exponent that's fractional, I would write it as ny and then x inside here with a 3 there. So although the y is outside, it doesn't make much of a difference in this situation in terms of the position, just because y should be out on the outside. All right, so let's go to this next one. All right, so now we have just numbers. So I know that I want 27 here. I'm looking for the third root, and then I want to square it, right? So the third root of 27, well, that is just some number that multiplies to itself 3 times, which is 3, and then I want to square that. So the answer is 9. 27 raised to the 2/3 powers is 9. So what is 16 raised to the 4/5 power? Okay, so here's 16. I want the 4th root, and then I want to raise it to the 5th power. I can calculate that. I could do 16 to the 5th power and then find the 4th root. I could have done 27 to the 2nd power and then found the 3rd root. But it's not such a bad idea to just take, if it works, to take the 4th root first. And in fact, I can take the 4th root first. I get the 4th root of 16 is 2, and then 2 to the 5th power is 32. So we've worked through these kind of 7 examples, which kind of guide us back and forth between them, which is very useful for kind of seeing the different formats and different setups that you could receive. But there are some nuances of difficulty with this, and let's see if we can't come to an understanding of that difficulty level in the next video.